Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 3, Matrix Multiplication. Very, very different from adding and subtracting matrices. So let's see if we can wrap our heads around multiplying matrices. So first of all, not all matrices can be multiplied. We have to do a quick check to see if it's possible. And what we look at is if the number of columns in the first matrix is the same as the number of rows in the second, then it's possible. So the best way to explain this is to look at some examples. We have three matrices here, A, B, and C, and we're going to determine if these products are possible. So is it possible to multiply A times B? Well, we need to look at the dimensions of the matrix. A is a 2 by 2, B is a 2 by 3, and the number of columns is this number in A, the number of rows is this number in B. So if these two middle numbers are the same, then yes, it is possible to multiply A times B. And then we'll answer this second question in just a moment. So is AC possible? Can you multiply a 2 by 2 multiplied times C is a 3 by 3? And if these two numbers are different, no, they cannot be multiplied. We wouldn't waste time entering them on our calculators. Okay, is BC possible? This is a 2 by 3. Can we multiply that by a 3 by 3? These two middle numbers are the same. Yes, we can. Can we multiply B times A? B is a 2 by 3. A is a 2 by 2. Since these two numbers are not the same, no, they cannot be multiplied. And now this other question we're asked, what are the dimensions of the answer? Well, the solution, after you multiply these two matrices, the solution dimensions are right here. If they can be multiplied, so if that's a yes, then our answer is going to be a 2 by 3. This one can't be multiplied, so we're not going to bother. This one can be B times C. These two numbers match, and so this solution also is going to be a 2 by 3. And this is kind of handy to know what the solution is going to look like once you start multiplying. So let's try multiplying a 2 by 2 matrix times another 2 by 2. Now I put this on here with letters sort of like a formula for people who like that. So what this is saying is this row is going to be multiplied by this column. That's what AE means. So you take A times E, get that answer, take B times G and add them. So this row times this column gives us the first entry. Now for the second entry, we take the top row, A and B, and you multiply it by the second column, A times F plus B times H. That gives us this second entry. And then we switch to the bottom row, take this bottom row times this first column to get this entry. And I don't know if I have another color here. Doesn't look like it. So I'm going to use red again. And then for this last entry, we take this bottom row times the second column, C times F plus D times H, to get this entry. Now if you don't like all those letters, I understand. Let's do this with numbers and it might be more clear. So we're going to take this row times this column. We take this 4 times 3 is 12, and we're going to add to that -2 times -3 is 6. So I'm going to write the sums here and then we'll put the answer matrix next to it. So now for the second entry, we take this row times this column. 4 times 6 is 24, plus negative 2 times positive 2, so I'm going to put minus 4. And I'm just going to go ahead, it's kind of bothering me, I'm going to write the answers here. 12 and 6 is 18, because you're probably not going to write that middle step. You're going to just go write 24 minus 4, you're going to write 20. But just for this explanation, I'm going to put in this middle step. So now we got to work on our bottom row. So we use this bottom row times this first column. 1 times 3 is 3, plus 5 times negative 3 is negative 15, which gives us a negative 12 element right there. Again, take this bottom row times this second column. 1 times 6 is 6, plus 5 times 2 is 10, so that last entry is 16. So take a look at that and ponder that and see if you can get your mind going with matrix multiplication. Here's another example we can look at together. We're given A and B, two matrices, and we're asked to find AB. So before I do a product, I like to make sure it exists. So A is a 2 by 3 matrix. B is a 3 by 2 matrix. Since these two numbers match, yes, it exists. And my answer is going to be a 2 by 2. So like I said, I like going into it knowing that I'm going to have a 2 by 2 matrix. So we're going to multiply this first row times this first column to get our first entry here. So this is kind of my thought bubble over here. 2 times 3 is 6, 4 times 5 is 20, and 0 times 1 is 0. So my first entry is 26. Now to find this other entry in the top row, we're going to take this row times this column. And here's my thinking bubble over here. 2 times 4 is 8, plus 4 times 2 is 8, plus 0 times 0 gives me the second entry of 16. Now we're going to use the bottom row. The bottom row times the first column. 3 times 1 is 3, plus 3 times 5 is 15, plus 5 times 1 is 5. And if we add those up, we get 23. And then to get this last entry, we take the bottom row times this second column. 1 times 4 is 4, plus 3 times 2 is 6, plus 5 times 0 is 0, leaves me with 10. So now the question that was asked here, would multiplying B times A give us the same matrix as we got when we multiplied A times B? And if you attempted to do this, it would be a very different matrix. If you multiplied B times A, that would be a 3 by 2 times a 2 by 3. Your answer, this would be if we did BA, your answer is going to be a 3 by 3 matrix, not even close to this answer. So when we are asked this, are they the same, commutative? Absolutely not. Matrix multiplication is not commutative at all. So I restated this very clearly here. You can tell it's important because I put 3 stars there. AB is not equal to BA for matrices. Multiplication in matrices is not commutative. And this is going to be very important when we start solving matrix equations. It's not equal, and sometimes one of the products may not even exist. This next part, we did talk about adding identities in section 2, so here we're going to talk about a multiplying identity. Now every single matrix had an additive identity when the matrix is all full of zeros, no big deal. But now in multiplying, only square matrices have an identity. And the identity would be represented by this letter I, such that if you took the matrix times the identity, you would get the matrix. If you took the identity times the matrix A, you would still have A. It did not change A at all. So we need to look at what that identity would, what that matrix would look like. And so this is the best way I know of to show you that. A multiplying identity matrix has ones along this main diagonal. The main diagonal is the row that starts in the top left and goes down to the bottom right. All of these would be ones. Everything else in the entire matrix is zeros. These dots are intended to show you and so on. You know, all these entries are zeros. Only this main diagonal running right along here are ones. Now, if you multiplied any matrix, any square matrix times its identity, you'd be just taking that first element times 1 and the rest would be zeros. The second element times 1, the rest would be zeros. So you're not going to change the matrix at all. Now, one of the great things we're going to use matrices for is for solving systems of equations. If you remember, the extra credit in your last test had 4 equations with 4 variables, which is a nightmare to solve with just substitution or elimination. So eventually we want to be able to solve this. But for today in this section, we're just going to take this systems of equations and we're going to rewrite it as a matrix equation. So we're going to take these and just put them into a matrix. We're not going to solve it yet in this video. That'll come in the next section, or maybe the section after that. So what I want to give these matrices categories. The first matrix is, I call it the coefficient matrix. This is where we're going to pull the numbers off of the x term, the y term, and the z term. So we have a coefficient matrix, and then we're going to have a variable matrix that's going to have our x, y, and z in it. And then we're going to have our answer matrix. So before you start pulling these numbers out to put into a matrix equation, please make sure everything is lined up like this. The x's are first, the y, the z, the equal sign, and then the answer. So first, the coefficients. Just pull the coefficients off of their term. The first x coefficient is 3, y coefficient 1, and the z is -4. From the second row, we have a 2, 3, and a 4. And from that last row, we have 1, -1, and 2. So there's our coefficient matrix. And we're going to multiply that times our variable matrix, which is just x, y, z. Now, remembering what you know about matrix multiplication here, if you took 3 times x, you'd get 3x, 1 times y is y, and -4z, which is just what we had right here. So if you multiply these two matrices we just made, you'd get right back to these equations. And then the answer matrix is just the 3, is the 3 numbers that we have. So we have a -22, a 32, and 16. So that's what we're accomplishing today, is taking this systems of equation and writing it as a matrix equation. And we're going to learn how to solve this soon, but not in this section. All right, the last thing I have on my notes here is just a little practice. So before I multiply a matrix, remember I always want to check to see if the product exists. So we have a 2 by 2 here, and we're multiplying it by a 3 by 2. Since these two numbers don't match, this product doesn't exist. I'm not even going to bother with it. That's just a no. So here we have a 2 by 3, and we're multiplying it by a 3 by 1. Yes, the product exists, and my answer is going to be a 2 by 1. All right, so I'm going to go ahead with it. this first row times this column. 7 times 1, I guess I'll write my thinking bubble over here. 7 times 1 is 7. 8 times 2 is 16. And negative 4 times 3 is negative 12. So then if we would add those together, we would get 11. So that's the first entry in my 2 by 1. Now let's take this bottom row times this column. 1 times negative 5 is negative 5. 2 times 0 is 0. And 3 times 3 is 9. 9 and negative 5 is 4. So that's my answer for that product. All right, I believe you have all the knowledge you need to do section 3. So have fun with math.